So, hello students. My name is Karthik Bansal, and a little background about me. I did my schooling from Lancers Convent in non-medical stream. After that, I did my graduation in mathematics from Delhi University, Zakir Hussain Delhi College, and after that, I have worked as a subject matter expert in mathematics with NCI Ready Services for 3 months. So, in today's class, we will be learning about introduction to trigonometry, the basic things, what trigonometry consists of, and other terms related to trigonometry. So, we shall begin with introduction to trigonometry from the next slide. Okay. So basically, trigonometry is made up of two Greek words. The first one is trignon, which means three angles, and the second one is metron, which means measure. So when we combine these two meanings, these two mean the measurement of three angles. So basically, trigonometry is consists of studying triangles, but it consists of a special type of triangle, which is known as right-angled triangle. Okay. So till now we were dealing with 2D shapes like square, rectangle, triangle. Triangle has three sides, square has four with all the sides equal. Rectangle has four sides with opposite two sides equal. So all these are 2D shapes with different number of sides and different uh, different angles. Okay, here in trigonometry we will deal with triangles only, and with the type of triangles which have 90 one angle always will be 90 degrees. So let's come to the next point. Trigonometry is a branch of mathematics which deals with triangles. Okay, particularly triangles in a plane where one of the angle is 90 degrees. So basically, a triangle is a 2D shape which has three sides and three angles. So in trigonometry, we will study those type of triangles which have one angle as 90 degree. Okay, only one angle. Okay, let's move forward. Before moving forward, I would like to tell you that a triangle has three sides and three angles, and sum of all the angles is 180 degrees. Okay. So in trigonometry, we are studying right angled triangle in which one angle is 90 degrees. So 90 plus added to it, the sum of other two angles will give us 180. So this means that the sum of other two angles will always be 90 degrees. This is a very important thing which you should make a note of. Okay. So the next point comes here is triangles on a sphere are also studied in spherical trigonometry. So here the basic thing I would like to state is that we are studying introduction to trigonometry, and spherical trigonometry as of now is not our area of interests, but you will study it in higher classes. Okay, so let's move to the next point. Trigonometry specifically deals with the relationships between the sides and the triangle and the angles of triangles, that is on the trigonometric functions and with relations based on these functions. So basically, we use theta as the naming of theta, gamma, alpha, beta as the naming of other two angles, and based on these angles we derive some functions, we use some trigonometric terms, and this is how we will proceed. Okay, so let's move to the next slide. Okay, so starting, I told you, see, this is a right angled triangle. Okay, this thing, this over here is a right angled triangle, wherein this angle C is 90 degrees. Okay, and these are other two angles, and these are the sides. I told you a triangle is a 2D shape which consists of three sides and three angles. So AB, BC, AC are the three sides respectively, and angle BAC, angle ACB, and angle ABC are three angles respectively, wherein angle ACB is equal to 90 degree. Okay, so let's start reading. In any right triangle means an angle is 90 degree. Or one of the angles is 90 degree. in the triangle, then it is a right triangle. Okay, so in any right triangle, the area of the square whose side is the hypotenuse is equal to the sum of the areas of the squares whose sides are the two legs. Okay, so basically Pythagoras was a mathematician who gave Pythagoras theorem. According to this theorem is first of all only valid in a triangle whose one angle is 90 degree. So that means Pythagoras theorem is only valid for those triangles which are right triangles or which are right angled triangles. Okay, see, this is a right angle triangle because angle ACB is 90 degree. Okay, and sum of all the angles of a triangle is 180 degree. Okay, so according to this Pythagoras theorem, the sum of the perpendicular and the base is equal, the sum of the squares of perpendicular and the base is equal to the sum is equal to the square of the hypotenuse. Now what is perpendicular, what is base, and what is a hypotenuse? So in a right angle triangle, the hypotenuse is the longest side. The longest side is the hypotenuse. Okay, this side, this thing, this is what we call as hypotenuse. Okay, we can denote it with h. Okay, let me write it for you. Okay, now the other two sides, which are the adjacent sides, so this is the perpendicular. Okay, which is denoted by p, and this is the base. Okay, which is denoted by b. So basically h square is equal to p square plus b square, or c square is equal to a square plus b square, c. Okay, now further concepts that I would like to tell you over here is, see, I can denote this angle, okay, this angle BAC as theta. Okay, the sign of theta is this, and this angle as alpha. Okay, this is the sign for alpha. Now one concept that I would like to tell you over here is that the side which is opposite to the angle becomes perpendicular for it. Okay, so perpendicular for theta will be A, that is BC, but perpendicular for alpha will be AC, that is B. Okay, so these were the basic concepts, and this was the Pythagoras theorem. So Pythagoras theorem basically means h square is equal to p square plus b square, wherein h stands for hypotenuse, p stands for perpendicular, and b stands for base. Okay, so let's move to the next slide. Okay, so likewise, as I told you in the previous slide, that Pythagoras was a renowned mathematician who gave Pythagoras theorem, wherein h square is equal to p square plus b square, wherein h stands for hypotenuse, p for perpendicular, and b for base. So these are some of the important Pythagorean triplets which you can try to remember and which can be proven also. See, taking the first um, triplet, see, square of 3 is 9. I will write it for you over here. Square of 3 is 9. Square of 4 is 16. Okay, and square of 5 is 25. For those students who do not know what is square, see, square means multiplying the number by itself. For example, I wrote 9 above 3, which means 3 times 3. The square of 3 is 9. Likewise, the square of 4 is 16, and likewise the square of 5 is 25. Also, this can be understood as the area of a square whose side is 3. See, if I construct a square over here, okay, this is a square, and I say that the side of the square is A, which is equal to 3. So everyone would be knowing the area. What is the formula for the area of area of the square? That is a square, which means side square. Okay, so the square of 3 will be 9. Okay, similarly, a square of side 4 centimeters or 4 millimeters or 4 units will have area 16, and same goes for 5. So these are the Pythagorean triplets. You can learn them, and also you can try to remember them as they are important for further classes and for further use. Okay, so likewise the square of 5 is 25 and that of 12 is 144. So 25 plus 144 is 169, which is the square of 13. Okay, so let's move forward. Okay, now we will start with the real trigonometry. What we I say would be the real crux of trigonometry, the functions that come in trigonometry. Okay, so see, here you can see this thing. This is, what is this? This is a right angled triangle. Why? Because one of the angle is 90 degrees. Okay, this is the longest side, which is denoted by hypotenuse. This is the adjacent side, or we can call it base also. And this is the opposite side, which can be called as perpendicular also. So see, sine theta. Theta is the angle, which is denoted over here. Okay. So what is the value of sine theta? We will see in this table in the respect of this triangle. Okay. So sine theta is equal to opposite upon hypotenuse, means this side upon hypotenuse. I can name this side for you. Let this be A, this be B, and this third edge be C. So the value of sine theta here will be AC upon AB. See, I told you earlier also that with respect to the angle that we are writing the value of sine theta, the perpendicular will be the opposite side of that angle. So see, in this circle, in this triangle, this side, the side AC, is opposite to angle theta. So this will act as a perpendicular for this particular angle, which is denoted by theta. So the value of sine theta will be AC by AB. AB is the longest side, so it is the hypotenuse, and AC is this side, which is opposite to theta. Similarly, cos theta, which is cosine. So cos theta is adjacent upon hypotenuse, or we can say as BC upon AB. Okay, so the I told you earlier also that the side which is opposite to theta acts as the perpendicular. So the side which is not opposite to the angle theta and which is adjacent to it, the shorter side, shorter than hypotenuse, will act as the base for it. Okay, so the formula of cos theta can be summed up as base upon hypotenuse. Similarly, this formula for sine theta, the expression for sine theta can be considered to be perpendicular upon hypotenuse in respect to this angle theta. This is the main thing that we need to stress upon and learn, that the side which is opposite to the angle theta acts as the perpendicular, and which is the adjacent to it and shorter than the hypotenuse acts as the base. And this hypotenuse is the longest side in a triangle. These three terms are very necessary to remember, which are perpendicular, base, and hypotenuse. Okay. Now coming to tan theta. So tan theta is the ratio or the division of perpendicular and base. So as I told you, tan theta, with respect to this angle theta, the perpendicular will be AC, and the base will be BC. So these are the important terms, important functions of trigonometry, which need to be remembered. And the fact, and the one thing that should be noted over here is that the side that will be opposite to the angle will act as the perpendicular for that particular angle, and the side which is shorter than the hypotenuse and adjacent to the angle theta will act as its base. Okay, so again I am repeating, sine theta will be equal to perpendicular upon hypotenuse, where perpendicular is the side that is opposite to the angle which we are writing the formula for. Similarly, cos theta will be equal to base upon hypotenuse, and tan theta will be equal to perpendicular upon base. Okay, so you can note it down, pause the video, note it down, and we can move to the next slide. Okay, these are the important necessary things which need to be remembered. Yeah, so in the previous slide, we learned about the basic functions of trigonometry, that are sine, cosine, and tangent. Okay, the value of sine theta will be in respect to the angle that we are seeing. The side that will be opposite to theta will be the perpendicular, and the other side, which is shorter than the hypotenuse, will be the base. So the value of sine theta will come as perpendicular upon hypotenuse. Similarly, the value of cos theta will come as base upon hypotenuse, and the value of tan theta will come as perpendicular upon base. Okay, so now moving forward, we will learn some other trigonometric identities and functions. Okay, first of all, we will learn about this one, these three identities. Sine square theta plus cos square theta is equal to 1. So these are the basic three identities on which trigonometry is based. So this should be learned by heart. Okay, I can also prove one identity for you. See, we just learned that sine theta is equal to perpendicular upon hypotenuse. Okay, so sine square theta will be perpendicular square upon hypotenuse square. Similarly, cos theta is base upon hypotenuse, so cos square theta will be base square upon hypotenuse square. Okay, now taking the LCM as h square, that is hypotenuse square, we get p square plus b square. And according to Pythagoras theorem, what is p square plus b square? Is it h square according to the Pythagoras theorem? Yes. So h square upon h square, and these two get cancelled, so the answer here will be 1. Similarly, tan theta is sine theta upon cos theta. See, written over here. Okay, and these things need to be remembered. See, sec theta is 1 upon cos theta, or cos theta is 1 upon sec theta. Both things are right. Okay, cosec theta is 1 upon sine theta, cot theta is 1 upon tan theta. So secant, sec is the short form of secant, cosec is the short form of cosecant, and tangent is the short form of tangent. So these are the reciprocal functions. Okay, we can say them reciprocal functions. Okay, so these are complementary angles. Okay, sine theta is equal to cos 90 minus theta, cos theta is equal to sine 90 minus theta, tan theta is equal to cot 90 minus theta. Okay, so basically these things you will learn in higher classes, but you can remember for solving questions these formulas and these questions, as they are very necessary. See, sine square theta plus cos square theta is equal to 1. We just proved it over here. Tan square theta plus 1 is equal to sec square theta, or sec square theta minus tan square theta is equal to 1. You can also prove it. Sec theta, the value of sec theta for a triangle is given by hypotenuse upon base. Okay, and that for tan theta is given by perpendicular upon base. So you can prove these functions or identities by taking in view the triangle which is shown in the previous slide. Also, I can write it for you here, that sec theta is equal to hypotenuse upon base. And in the previous slide, we learned that cos theta is equal to base upon hypotenuse. So see, these both are reciprocal of each other. Okay, so this thing you need to remember, that sec theta is the reciprocal of cos theta, cosec theta is the reciprocal of sine theta, and cot theta is the reciprocal of tan theta. Okay. Yes. So you can note it down and then we can move to the next slide. Okay. So these are the trigonometric ratios of some specified angles. So this table needs to be learnt by heart. This is a very important table which is used in this standard as well as in the next standard and throughout the life in any of the examinations. This is a very important and a very basic table of trigonometry. Okay. So the value of sine, this table is read as I'm reading it now. The value of sine theta at 0 degree will be 0. Okay. The value of sine theta at 30 degree will be 1 by 2. The value of sine theta at 45 degree will be 1 by 2, 1 by root 2. And the value of sine theta at 60 degree will be root 3 by 2. And the value of sine 90 is 1. Okay. So basically these are the values of sine theta at different angles. Okay. You can learn them also. And tan theta is sine theta upon cos theta. So this table can be derived as a these things can be written based on these two only. So you can see there one important thing to note over here is that the values are repeating themselves in uh, a flip way. Like, see, one is coming here and one is coming here, then root 3 by 2, root 3 by 2, 1 by root 2, 1 by root 2, half, and 0 0. So basically you just need to flip the values of sine theta in order to get cos theta. For tan theta you need to divide sine theta by cos theta. For cosec theta you need to just reciprocate the values of sine theta. For sec theta, you just need to reciprocate the values of cos theta. And for cot theta, you just need to reciprocate the values of tan theta. So if you are able to learn the values of sine theta, then you will be able to make the whole table by your own. Okay. So this is a very important table. Okay. So this is basically the quadrant that we see in a bar graph, which is been divided into four quadrants. The first quad in the first quadrant itself, all the angles are positive. See, all positive. It means sine, cosine, tangent, cotangent, secant, cosecant. All the angles are positive. This the area of this quadrant is from 0 degree to 90 degrees. Okay. Now coming to the second quadrant, here only sine and sine and cosecant are positive. Okay. So this the area of this particular quadrant varies from stretches from 90 degrees to 180 degrees in this particular figure. And for the third quadrant, the area stretches from the area stretches from 180 degrees to 270 degrees, in which tan theta and tangent and cotangent functions are positive. Now coming to the fourth quadrant, cosecant and secant functions are only positive in the fourth quadrant, which stretches from 270 degrees to 360 degrees. Okay, so these are the things which you will study in detail in further classes, but these are the basic facts regarding this particular figure. Okay, so let's move to the next slide. Okay, so now we come to the end of the session. So for thank you for being patient listeners, and we will meet with some new slides and new topics in the next lecture. Thank you.